So 308, let's do some answers and then give some help on this. 308, the first group was about combining like radicals. So 3 should have been 3 cube root of 5. 9, we'd get 6 cube root of 5. 15 is 38 root 5. 21, I got a 4 cube root of 4. 27 is a little weird. You'd have a cube root of 3x, and out in front of it, in parentheses, a 2 minus x. 33 is a little weird. You'd get under the root an x minus 1, and then out front in parentheses, you need an x plus 3. That's all the odd answers, which you already had access to in the back, so maybe you checked those already, maybe you didn't. If you're getting those right, the evens should work, but I can help you on any even or odd if there's anything there that you've just got a flavor for something, and if you're like, wait, how do I do something?
60?
Just up to 33 for just a second. Anybody up to 33, anything?
33.
33. So 33, put a little board space here. So when we go to tackle 33, this first root, we're going to have to rely on a little bit of an old skill to try to get that one fixed up a little bit. This second root, we're going to have to use an old skill to get this fixed up a little bit. What old skill am I going to need to attack either of those?
The one on the right is the difference of squares.
It's close, but not quite to a difference of squares because it's not an even power on that. Yeah, GCF. Here we could take out 9 leaves x minus 1. How about this one? X squared can come out x minus 1. So both of these are like because under that radical they have
X minus 1.
x minus 1s. So when we get to our answer form, we're going to have under those roots x minus 1s because those are just stuck under there. Question about that half of it. Okay. Then square root of 9. What is the square root of 9? 3. This had a plus. And for this, what's the square root of x squared? X. If we wrote it like this, we're not quite right, but we're pretty good. But question about how I got to there? Okay, this isn't perfect because this looks like the root only goes with the 3. The root did go with the 3, but the root also went with this. The root went with everybody. So to show that the root goes with everybody, we'll need a set of parentheses there to show. That makes sense? Anybody else first? 33? Anything about that? Okay, starting on 35, we're going to distribute or FOIL. And one of the things that keeps happening is you keep running into stuff like root 11s, multiplying root 11s. And the shortest way to do that is to just write regular, good old-fashioned 11. If a root multiplies itself, as long as it's a square root times square root, just write the number and erase the square root sign. That's the quickest way to accomplish that mission. I'll read you the odds. If you already checked your odds, you're not getting anything out of that, but at least it verifies the odd ones in the back that you could have accessed. 39 is a 2 root 15 minus 6 root 3. 45 is going to be 1 as a best answer once you combine. 51 is a 1 plus root 5. 57 would be an A plus a root with 3A plus a root that covers 2A plus a root 6. 63 is 21 minus 6 root 6. And then I'll field questions. We already had a question on 60. So if we go to do 60, the numbers in front can only multiply the other numbers in front. So when I have the 3 thing take on the 2 thing, I'd get a 6, I'd get a 4th root, and I'd get a 63. Are you okay with that?
Yeah.
Then you tell me what would be one more piece. We're going to get 4 pieces. What's one more piece you could see that's coming?
2 and then 4th root. 54.
That's true. Can you spot another one?
A minus 3 fourth root 36.
True. And then one more?
Minus 9 the fourth root is 42.
Correct. Then we'd have one hesitation before we declared victory would be, we have that table with like numbers, squares, cubes. One day I built fourth powers. 2 to the fourth is 16. 3 to the fourth, we're already up to 81. 81's too big to help us. If 16 went into any of those numbers, we would attack that. But does it? Does 16 go into any of them? No. So you just declare victory and move on. But if you had something like a 32, then we could simplify.
Yeah.
Anybody else have anything up through the 35 to 64 zone where we were trying to foil and distribute a good bit? Anything there that's problematic? Okay, rationalizing, it's easier when it's a square root on the bottom. 69's problem, I'm going to say, is 2 root 15 over 5. If you have an answer that had a 6 over a 15, you just need to reduce. The best answer is 2 root 15 over 5. 75 is a cube root, so that one's a little tricky. I think we already hit that question. I think we got a question about that yesterday. I think, did Luch, maybe, did you ask about that one? I think. So we worked out 75 yesterday. It was going to be a y on the top, and then under the root on top, a cube root of 9yx squared. The bottom has a 3x squared. 81, they start to add or subtract on the bottom, so that makes us use the conjugate, and I think we did a reteach yesterday about that, but I don't think I did any of these questions. But 81, I'm going to say negative 2 root 35 minus 2 root 21, and then 87 is where we stopped. 87, I'd say 3 root 6 plus 4, all on the top, 2 on the bottom. There's at least the odd half of that for you just to do some checking. If the odds work, the evens will work. Anybody need me to reteach anything from the 65 to 87 zone?
84.
84. 84. 84, I have root 6 minus 3 root 5 after a small chalk change. So the way we fix these, we look at the bottom, we're going to multiply by some of the same stuff. If we want the root 3 to go away, we're going to have to multiply in some way by root 3. To fix that 2 root 7 stuff, we're going to need to go and use 2 root 7. Whatever we do to the bottom, we've got to do the same to the top, but with a small tweak. Switch the sign. And that has a fancy math name that's called conjugate. You okay with that basic strategy?
Yeah.
Okay. And then it becomes just an exercise in foiling. I like to do the bottom first because it's usually just easier to do the bottom. This would be a mess, but I don't care about it
Because it's gonna.
because it's going to eliminate the other mess. Root 3 times root 3
3.
is a regular old 3.
Does that make sense? Oh, excuse me, I'm sorry.
Okay.
You're forgiven this time.
Yes.
I did interrupt.
Okay. I'll see what he thinks of that. You agree with me that? Okay. Yeah, root 3 times root 3, that's a regular old 3. How about the 2 root 7s? Warm?
Negative 14.
Warmer. When we multiply these, the root 7s will make 7. But there's 2 2s. 28, because the two twos make 4. So this makes a 4, that makes a 7, that's a 28. The bottom would be negative 25 for a second. Anybody not good at the bottom? Top, we're going to get 4 things out of it. What's a thing we get if we are foiling? Anybody just yell something.
Root 18.
There is a root 18. Anybody just yell another thing we're going to get out of the
Negative 6 root 35.
negative 6 root 35, yes.
2 root 42.
A 2 root 42, yes. And then there's one more thing in there
3
somewhere.
root 15.
2 root
Negative
15?
3 root 15.
Negative 3 root 15 is in there, that's all true. Anybody not okay with the FOIL? And then the question is whether any of these squares can help us. The biggest number I have is 42, so I'll go as far as 36. Can any of those squares go into any of those numbers?
Yes.
Yeah, who?
The 9.
9 goes into 18. So instead of 9 and 2, 3 root 2, and that's the best we can do out of that. Is that okay? You good there?
Yeah.
Anybody else, anythings from page 308? That was due yesterday with semi-success, but the day before that was the day that this class was sort of wiped out by absences. Anything there? I think you were out for that lesson. Are you good now?
Yeah, I think so.
Anybody? So then let's go 315. So 315 is our newest friend. So let's rattle through some 315 stuff. We skipped the 3's, right? Yeah. Okay, so 1, I'm going to say 6a root 6a. 5, I'll say 54a cubed b, and then a root 2b. 7 is a 2c, and then a cube root of 18cd squared. And my opinion is that's the hardest group. I think the first group was the hardest group of this homework. Anybody need some guidance on something there? Yeah, so there's 2 things that can happen on this group. If you can do the root first, we decided that doing the root first would be easier. If you can't do the root first, you kind of like have to do the power first, make everything bigger, and then worry about the root. That was like the basic strategy. You just were mad at the whole group?
Yeah, I just
Okay. Is there anybody that did the group and you're mad at a particular one more than you're mad at the rest of the group? We'll do that one, or we'll just randomly pick one, I guess. Anybody have something 1 to 8 that you thought was worse? You pick, randomly pick one, which number you want me to hit. If it's your request. Pick any number, 1 to 8. 8. Okay, so for 8, we can't cube root the 9. So what I would do for that is just leave the cube root alone and just do the powers. So 9 times 9 would go up to 81. X squared is up to x to the 4. And then the y gets squared. You okay with that? I think the variables are actually easier to do than the numbers, personally. So with 3 and 2, that 2 is too little, just don't mess with it. 3 is big enough, or 4 is big enough for 3 to help us out. 3 into 4, we come out with x, and in stays x. And with 81s, our cube column goes 8, 27, 64, 125. So, do any of those numbers help you? Get help from our room. With 81, do any of those help? 27. 27 into 81 goes 3. So in stays 3 because of that, and the 27 because of our chart outcomes of 3 as well. You okay with that? Well, minor mistake that I make here,
Index.
index, always remember to get the indexes back. Is that okay-ish? If you're good at mental math, this chapter is easier for you. If you're not good at mental math, you spend a lot of time probably on your calculator doing things like, does 81 divide 8? Nope. Does 81 divide 27? Yep, let me do it. Or a question like this, you might be sitting there going, does this divide by 4? Does this divide by 4? Does this divide by 4? No. Does that divide 9? Does that divide 9? Does that, you know, you're just sitting there all the time trying numbers, and a lot of times the answer is no, but sometimes it's yes. Anybody first 8? Next group, fractional powers. If I say there's an x and I go with like a 3 and a 4, and I want radical style, is this the 3 or the 4?
That's the 4.
That is the 4. That is the 3. I think this section was one of the easier sections of this, because you're just writing it like that. 11, when you write the radical, it's a radical you can do, so best answer on 11, they think is 2. But based on the directions, if you just wrote the cube root of 8, I can't say why that would be wrong, because they didn't say to simplify. They just said to rewrite it. So if you wrote cube root of 8, I wouldn't argue with that. But if they think 2 is better, I can't argue with that either. 13, we go cube root, no, 5th root, and then under there an a squared b squared. 15, we skip 17. If you wrote the 4th root of 16 cubed, I can't argue with that, but the 4th root of 16 is doable. What's the 4th root of 16? 2. So 2 cubed, which makes 8, they think is the best answer. 19 is 20 to the 1/3 power. 23 would be CD in parentheses to the 1/4 power. 25 would be parentheses around x, y squared, z. It's all in the 1/5 power. 29 would be parentheses around the 8x squared y. It's to the 5/7 power. And then let's call timeout on that. That all had to do with those fraction powers and the idea that I just hit a second ago. Anybody need guidance up to 30? At 31, they switched to negative powers. Negative powers flip things. So 31, I'm going to say 1 on top, and it's x to the positive 3rd. 35 is going to be a 10, and it's to a positive 2/3. 37 is going to be an x. It's going to be to a positive 2/3. And let me hesitate there. Every answer from 31 to 38 should have a positive power now. When you flip it, the power changes into positivity. Anybody to 38 need guidance? At 39, they're doing 3 ideas. When you multiply with the same bases, the powers have to...
They have the same bottom.
True, because we're going to do what to them?
Add.
Add. So if we did 39, we would need to add the powers. We did do 40, add the powers. When we change to divide on 41, we're going to subtract the powers. So 41 still has a 7, just a new power of 1/4. 42 we skipped. 43 you would subtract again the powers, keep the 8.3, just the power is going to be 7/20ths. 44 we'd subtract the powers. 45 we skipped. How would we do 45 though? We're no longer adding or subtracting the powers, we're now going to multiply the powers. 46, that's the kind of thing you'd have to do. Multiplying makes you add powers, dividing makes you subtract, and powers with other powers, you multiply them. Anything to 46 you need guidance on, anybody? And then 47 has to do with just simplifying things. You probably want to write fraction powers if you don't know what to do with them. Reduce the fraction powers and then put things back. 47, they're saying cube root of a squared. 49 is no radical sign. You can do everything perfectly. It's just 2y squared with no symbols. 53 is no symbols, just m squared n to the 4th on top of a 2. 55 is a 4th root of r squared s. 57 is a square root of a 2ts. 59 is a sixth root, and under the sixth root, I don't think I would FOIL it out. I think I would leave an x that's cubed, and then in parentheses an x minus 2 that's squared, and I think I'd call it a day. 61 has a 12th root. It has an x plus y under the root, and then you could either have that in parentheses to a -1, or you could have put 1 on top. No, I'm reading the wrong answer, my bad, sorry. 61 is a sixth root, and then a plus b. 62 is going to have stuff on the bottom or a -1 power. I was reading that one for a second. 65 is going to be a t in front, and then under a root, a fourth root of s. So t in front of a fourth root of s, little 4 index there. And I can help you there. That's probably the second hardest group. I thought the middle was a little bit easier than the beginning and end. I think the end they got a little bit big again. Yeah.
How do you do like 47, 50, and 3?
Okay, so 47, we have the sixth root of a to the 4. So recopy that with an a, but do a fraction power. Do you think 4 over 6 or 6 over 4?
4 over 6.
4 over 6. Can you do better than 4 over 6 in math?
Yeah.
Yeah. What's better than 4 over 6? 2 over 3. Then put it back as a radical with that a going back under there. Is the 3 the index, or is the 2 the index? 3. And then put the 2 as a power. That's the kind of moves that you're trying to make on some of those. Other ones are more like 49. 49, if you try to do the cube root of 8, that's on the table. The cube root of 8 is just 2. And then for number 49, you can divide the 3 into the 6, and so it's y squared. It's just 2y squared. There's nothing too crazy about that one. Do you follow that one? So sometimes they just kind of work like number 49. Other times you might need to work through those fraction powers, like number 47. It's like 50-50.
Like on 50.
So
Like
number
I like
50,
5,
you're going to want to,
2.
yeah, the index is a 2, and then 50 is going to work more like 49 just works. Because the 2 can divide into those. But if you get down to like number 55, that 8 is too big to divide into those other numbers. You're going to have to do fraction stuff with those. 55 is more like 47. Basically, if this index is bigger than the power, write a fraction and reduce it. But if this index is smaller than the power, just divide it. Is that okay? Yeah.
I don't know what I did on 65. My
Okay.
answer is
Okay. So 65, the first thing I would do with 65 is divide, kind of like you did on 41, 2, 3, 4.
okay.
So I'd want to subtract those powers. So if we subtract with the s's, I'd have 7/12 subtracting the 1/3, common denominator of 12. So 1/3 is 4/12. So the s would be 3/12. The s's would work out to have 1/4 power if we subtract their powers. You good on that?
I still have
Okay. So the t's, if 5/6 subtracts -6, that's the old minus minus make plus. So 5/6 would add the 1/6, and the t would be 6/6. In other words, 1. So the t is just like a t. The root died because it ended up being a whole number power. Are you good with that?
Yeah, I didn't see why those.
And then this we can return to radical form with just like a 4.
Yeah, I see
If you wrote that, that wouldn't be wrong, but for some reason, well, I know the reason, I can tell you the reason. They prefer to put the whole number stuff in front of the radical.
I just didn't see the minus,
Okay.
so I went a complete different direction.
Can anybody tell me why you think math community prefers this to this?
That one
Looks like it would be
messy,
decided.
looks like
Correct.
it's like root 2x.
This is definitely a 2 under and an x not under. This is definitely a 2 under and an x not under. But if I went like this, it's debatable, is that x under or not? So if you put the not under stuff first, it leaves no doubt. It's not a huge issue, but that's why the out stuff always goes first and the in stuff is second. Question about that? I also told you I'd explain why this is bad and this is good, because this actually looks worse than this. It just does. Okay, you have to realize there was a day before calculators existed. So if you wanted to divide this, you'd grab your calculator and you would not be mad. Okay? But in the old days, they would be pretty mad about this. They would not be mad about this. Okay? If we went to divide this, 2 would go where in the division life?
3 out.
3 would go out. And you'd get in here something like, I'm not sure what this even is, but it's like 3.4-ish. But this would go literally forever. So if you go 3 out and something in that goes forever, you can start to divide this. You know, is that division hard?
No.
No. Will you want to divide forever?
No.
No. But what you would do is you would just divide until you lost interest and think, that's good enough, I'll stop in the hundredths place, I'll stop in the thousandths place. If you were sending a man to the moon, maybe you need to go to the millionths place. But at some point you'd be like, okay, good enough. You could do that. If you set it up this way, the number that goes forever would go
From
outside. You'd get this 1.7 number that goes forever, and the simple number inside. And you can't even start to divide that. Like 17 would go into this once, but then you can't even how do you even proceed? Because your number that goes forever goes here. How do you even subtract that? That's a disaster. So they didn't want disastrous numbers here for their division life. They wanted the disastrous numbers there so that they could just give up at some point and round. And that just became a thing of make sure that the bottom, which is the divisor, is going to be a whole number and not have ridiculous Rudy numbers out there. That's the purpose of that.
Yeah.
Calculators got existed, so you're not as particular about that, but it just became a rule and people never just undid that rule. It's just a thing now. Anybody, anything about 316, 315, that's 66 question thing, anything about that for anybody? Yes, sir? 59? Okay, so 59, the square root of x, I'm going to do x to a fraction power. What fraction power, anybody in the room, is the square root stuff?
Bottom.
So we have square root of x, I want to write a fraction power out of that.
Oh, on top.
What? 1 on top of 2. Because this had an invisible 1,
I didn't know you.
that had an invisible 2, we're looking to go x to the half, you okay with that? Then we have an x minus 2. The x minus 2 was given to us as a cube root. So I'm going to go x minus 2 in parentheses. What fraction there?
A third.
A third. You okay with that?
Yeah.
Okay. So if we want to have these fractions be more agreeable with each other, we could force them to have a common denominator of
6.
6. Which makes this top
3.
3 and this top 2. You okay with that? Then we can have a rooting reunion. Who should the index be on both of those fractions? 6. The x has a power of 3. The x minus 2 has instead a power of 2. And I'd stop there personally. You follow that? What the book chose to do is FOIL this out, and then after they FOILed this out, what could you do to the X cube? You could distribute that in. That's what they chose to do. That's their answer in the back, is the thing that they FOILed and then distributed. I think it just makes it look worse. I think it's bigger, not smaller, to do that, so I don't do that. Anybody? 315, 316, any problems you hit that had you hung up on anything? Tomorrow is the review sheet. So review sheet tomorrow, 10 points if you try those all. We go on a weekend, we don't have school Monday, we come back Tuesday. Tuesday would be a quiz that's just like that review sheet. The little quizzes I was thinking we would maybe do someday. I just don't think we're going to do those because today we're down to like 6 minutes. It's not going to happen. I think tomorrow the review will probably keep us busy. If you did study that at all, you learned good stuff. You're readier for the quiz than if you hadn't studied it when we do the big quiz. But I don't think the little quizzes, time just isn't going to let us do that.
Well, he's not here now.